हेलो, माय नेम इज आदित्य प्रकाश। आज मैं जेट ऑफ चाओ सीक्वेंस के बारे में एक्सप्लेन करूंगा। जेट ऑफ सीक्वेंस आर द प्राइमरी मैनिफेस्ट ऑफ स्प्लिटिंग spectrum in a modern cellular system, including LTE and 5G NR. That is basically the replacing PN and wall sequence, which where is a mainstay of a 3G cellular. And these sequences are complex sequence with a unit amplitude and a particular phase shift. That means its amplitude is always be 1 and 1 or -1, and it change the phase shift. Okay, and basically ये जो है जो बाल्स एंड पिन कोड्स है उसको अपोजिट करता है। ठीक है, वॉल सीक्वेंस क्या होता है? वॉल सीक्वेंस इज ऑल्सो नो ए बाल्स फंक्शन और ए हार्मोन फंक्शन are a class of a mathematical function that is widely used in signal processing and digital communication. बेसिकली मैं इसके बारे में बताऊं तो ये बाइनरी वैल्यू सीक्वेंस होता है टू द पावर n लेंथ का, और एज फॉर एग्जांपल n इक्वल टू 0 के लिए 1 1 माइनस 1 1 1 माइनस माइनस 1 एंड 1 1 1 माइनस 1। दैट मीन्स द नंबर ऑफ -1 and +1 both are the equal. Then we can say that the Gauss sequence. That means that we can also conduct corresponding orthogonal set, right? So each Gauss sequence are orthogonal to all other Gauss sequence are the same length. This means that the inner product of any two distinct Gauss sequence is 0, otherwise it's the maximum value, right? That is about a Gauss sequence. And what is about a PN code? PN code is nothing but also known as a pseudo random noise codes, and that is also a binary code. That's application is basically in wireless communication, GPS and military radar. So in this case also simply that is the basically the random, but it's followed by or generated by the some deterministic algorithm. Okay, so its length will be also to the power n minus 1. M sequence is a p code that has a length to the power n minus 1. Where n is a positive number, the code has a good autocorrelation and cross correlation property. It has some property. And another type of PN code is the gold code, which is generated by the combining two or more MLS codes using the modulo 2 addition. You also said that XOR. Gold codes having good autocorrelation and cross correlation property. Okay, which are basically used in the GPS and other application in a timing and synchronization. Okay, so all about a PN codes and the wall sequence. Okay, and the JC sequence, B simply Zadoff-Chu sequence, B can write a JC sequence. We can say the JC sequence have a number of numerical and desirable property that will be defined in the next section. Basically its application in LTE and 5G NR, they are widely used for a number of important initial access or and overhead channel functions that are often overlooked by the engineer who focus on a data transmission. And for example, we can simply see that JC sequence are used for initial access in both the downlink and uplink. In the downlink synchronization and uplink in the random access. Uplink control information channels sounding, and for the reference symbol that's called pilot, used for a fine grained channel estimation. It is not an exaggeration to say that most types of signal other than the data transmission in a modern cellular standard utilize JC sequence. Simply we can define how to get JC sequence. JC sequence has a basically two parameters. One parameter is a Q, you see, one parameter is a Q and another parameter is an N, right? NZC, that is the, we simply say that the length, right? So you see that ZC sequence has two parameter. One is Q is equal to from 1 to Z NZC minus 1, and the length is NZC, which must be an odd number, otherwise or prime number. It depends upon. Give two parameter QZC sequence is defined as SQN is equal to exponential minus j pi q n into n plus 1 by NZC. The question arises that if the length is even number, how can you use Z of Chow sequence? So for this we can simply let us discuss later on, but for now sake of simplicity we can considered as a the length of the sequence is an odd number. Okay, and proceed further. So we define ZC sequence is such a way SQN is equal to exponential to the power minus j pi q into n plus 1 by NZC, where NZC is the length of an each sequence. And for example, if ZC sequence is used in a time domain splitting code in a DC DSCDM है. DSCDM मतलब domain splitting cumulative division multi-axis. And a splitting factor, the splitting factor is nothing but in a digital communication. In a digital communication system, the splitting factor is a parameter that is used to control the splitting of a transmission signal over the wider bandwidth. A splitting factor is commonly used in a direct sequence split spectrum system, which is used in many wireless communication application. So yeah, all are connected with this property. So we can simply say that NSF is equal to NJC. NSF मतलब कि the number of length of splitting factor is equal to the number of length of the ZC sequence. Okay, N denotes the time, and each user utilizes the different value of a Q. Okay, so cyclic shift and correlation. The cyclic shift means the how the rotated like that. If supported the B can rotate like a M sequence in a further way, so we write a XMN is equal to XN plus M mod N. That is the basically definition of a cyclic shift and the correlation, right? So we can write like that. Okay, so here is the define all integer M, and N is the unique cyclic shift. Cyclic periodic autocorrelation is defined in such a way that is the periodic, right? The periodic, that means the what? Simply you can consider as a backside also. So cyclic autocorrelation of a length n sequence xn is defined as that rxxt is equal to n is equal to 0 to n minus 1 x star n. X star n, that means the complex conjugate of x tau n, that means the order transpose happening, and n is the parameter of the, okay, small is the denoted the time, first time. So where tau is from 0 to n minus 1. Okay, and that is the complex conjugate of an xn. Normalize the cyclic autocorrelation, be fixed to the maximum up to the 1. So that's why we can normalize the cyclic autocorrelation. So we simply divide by the 1 by n. So its range will be from maximum range will be 1, and whatever the value of an periodic autocorrelation, that will be the less than 1 after the normalized cyclic autocorrelation. Okay, and for simply cross correlation, we can simply here denoted the x, and we can also in another sequence let us by n, then we can say that that's the periodic cross correlation of a two sequence. So in this case we simply write rx by tau is equal to summation n is equal to 0 to n minus 1 x star n by tau n, where tau is belongs to 0 to n minus 1. If by n is equal to x, then we can simply say that that is the autocorrelation function. And similarly 1 by n we divide by the n, then it's called a normalized cyclic cross correlation. Its value will be same. And let us discuss about some property of the ZC sequence. First property is about a constant amplitude. So in this case, we simply the amplitude will be always 1, and SQ always be 1, and only the phase changes. Only the phase changes from a sample to sample. This is described for the several implementation region. For example, peak to average power ratio of the sequence is always 1, also 1, because the amplitude is 1, and also limit to PMPR eventually continued time signal as well. So since the amplitude need not be computed, only the phase need to be the stored. So the benefit of this sequence is that you cannot be focused on an amplitude, only be focused on the phase changes. So only the data will be stored is nothing but only the phase needed, whatever. So another property is the zero cyclic autocorrelation. So the cyclic autocorrelation of ZC sequence is optimal in that it is a zero for all non-zero shift of the sequence, namely the unnormalized cyclic autocorrelation function of an SQN is equal to NGC delta T. Delta is nothing but a dot of sequence, right? Its value tau is equal to 0, its value will be 1, otherwise its value will be 0 for tau belongs to Z is the cyclic shift. So the first two property, after combining property, first one is constant amplitude and another property is zero cyclic autocorrelation. After combining these two, be said that constant amplitude, because the amplitude is always constant, so constant amplitude, zero autocorrelation relation sequence. So that is sequence such as the CAZAC sequence. And another property is a fixed cyclic cross correlation. If any two distinct ZC sequence of the time same length, supported the length is NZC, but one having the q root of q1 root of unity, and another one is q2 that is not equal to q2, not equal to q1. That means both are different, and we can simply normalize by the 1 by root under nzc, that is actually the length of the only the qth root of unity, that is the change. Otherwise root index is changed, but the length is same. Then our nzc is a prime supported, or more generally q1 minus q2 is relative prime to nzc. The only positive integer even divided by ngc, and q1 minus q2 is 1. So in this case the anomalized cyclic cross correlation is root under nzc. This is that's why this is the fair to optimal cross correlation for any two sequence with the optimal autocorrelation definable. So so we can say that if the nzc is the prime number, then nzc minus 1 is the such sequence. That's why we can choose an nzc is the prime, because we can get more number of sequences, right? So that's why we can prefer for a prime number. Otherwise the sequence will be less. If we take 4 2, then if we take 9 3, then only you cannot consider like a 8 sequence, right? So prime is also preferred for that. That is actually the reduce the good sequences. So that's the property of a, basically, to take a prime, index is a prime, even considered as an odd. All right. So now come to the property for, that is the DFT, discriminating Fourier transformation, or ID, inverse discriminating Fourier transformation of the ZC sequence, is also ZC sequence. Since the DFT of the sequence xn is the sum of the complex exponents with a rotating phase shift weighted by the sequence xn, if the sequence xn is a ZC sequence which itself is a rotating sequence of a phase shift, the result is also a ZC sequence. Similarly for the IDFT, Z sequence is also a Z sequence. The exact mapping of the IDFT or DFT of a Z sequence depending on the length of the NZC of the sequence and can be found in reference 1. So its benefits. What is the benefit of DFT? Why I am doing DFT and IDFT? The answer is that this be simply ZC sequence can be generated directly in the frequency domain without actually taking the DFT of the sequence. This is particularly useful for a OFDMA or a SC signal carrier frequency division multiple access, right, waveform that utilizes the frequency domain and the signalizing. Note that computing the FFT of the sequence of a prime length is quite inefficient, which make this property especially appealing, right? So now come to the sequence not for prime. If the sequence is not prime, then what we go for that? So for this we simply write a b. For this, we are applying ZC sequence. Most commonly, this means the sequence are the length NZC, where the NZC is the prime number. Through by addition possibility to discuss in the under property 3. So we can move an arbitrary length ZC sequence can be created from a prime length one using either cyclic extension or a truncation. However, the above important property 2 and 3 no longer precisely hold, although the loss may be the total level. So supported the if we found the number for a 12, so how can proceed? So we can proceed by the this relation, okay. So by this relation, so for to create a cyclic extension just order length, and SF be denoted by NSF, and NSF is nothing but a just NSF is the what are the length we can take to find, and NZC is the largest prime number less than or equal to the NSF. That means supported the bara 12 is the supposed that the NSF, then we can simply take the NZC is equal to 11, because that is the largest prime number, okay. Or why will taking 12, why I'm not taking like a 14 or something? So there are another importance we will discuss later on. So that we simply prep the necessary condition of the value of SQN, that is the SQN already defined in the upper section, like a SQN is equal to nothing but a, you see, SQN is an exponential of a minus j pi q n into n plus 1 by NZC, okay. So we can take a value from here. First of all, suppose we can take it NZC is equal to 11 and 1 modulo 11 is equal to 1, 2 modulo 11 is equal to 2 and so on h, right? And sqn matlab that means sqn whatever the q is defined, n is whatever the value for that, so that is the all we get. So we simply the necessary sqn is there on the back of the sequence of the top it off to the desired length. To create a truncated JC sequence orbital is also simple, just a JC sequence of length NJC is always will greater than equal to NSF, because the NZC is the prime number and less than equal to NSF, right? So fine. The cut of the length NJC minus LB value that is found. In practical cyclically extension sequence tend to be the preferred to a truncated sequence for reasons that are not entirely clear for me. Okay, so we simply how to generate it, that is generated by the example of a that is the example like exponential j 2 pi n into n plus 1 by q. So we will generate it from this where q is equal to 5. If we put n is equal to 1, then we get generated like exponential j 2 pi into 0 into 1 0 by 0, that means exponential 0, so 1. For simply put n is equal to 1 and we get this, n is equal to 2 we get this, n is equal to 3 we get this, as on it. So this sequence will extend, but we go for a supported we change like that if q is equal to 1, then the also the changes, and if for q is equal to 1 and only the shift changes 2, right? We can change the shift 2 only, right? Here the 2 means what, 1 2, that means this right here, this right here, this right here are the remaining part that is right here, and this right here. Okay, and simply add it after, then we can get the 0 plus 0 0, because that is the fifth root of unity we get, that means the 1 plus q square q3 plus q4 is equal to what, 0. So using this property we can get this sequence. Okay, okay. Okay, so now the if q is equal to 4, then simply we get this result, and you see that the if s10 and s40 both are the same sequence, if q is equal to 1 and q is equal to 4 both are the same cyclic autocorrelation property, so we can simply the normalize this thing with the root under NZC, there the NZC value is root 5, so its value will be 0.4472 for all possible such cases, right? Now come that is the example for an odd length. If we consider as an even length, then what we go for that? Suppose we can take a length 12. Okay, length 12, that means what? Length, if we take a length 12, that means NSF is equal to 12. Okay, so we can simply consider a largest prime less than 12 is 11. So NZC is equal to 11. So the exponential 2 pi by 11 into 0, because 0 modulo 0, 1 2 3 4 5 6 7 8 9 10. If 11 is equal to 11 modulo 0, that means 0, right? That is the consider up, we simply put we get the value of s thing, so we put in equation like s 0, then 0 1 into 1 into by 11, so 2 minus 2, because minus 2 pi, right, in a problem. So from there we can get this value. Okay, so for the z10 is this and z40 is 0, for q is equal to 4, that is the same in this equation. Both of these equations along with the other, and total are 11 and different to 12 cyclic standard AC sequence have the normalized autocorrelation, that is no longer a delta function, and autocorrelation to each sequence is different. So their normalized autocorrelation are plotted, you see in figure 1. Here is a for q is equal to 4 is the red graph, and q is equal to 1 is the blue. You see here is the basically the from this value, if q is equal to 1, that is the much better than the because the normalized correlation value will be less corresponding to q is equal to 4. See, so a common and zero value will be 1 by NSB 1 by 2 observed at the shift 1 to 10 and 11 in the plot. As opposed to the zero autocorrelation of for a prime length ZC, although it can be quite a bit higher as seen in the plot. Note that in the term of energy remaining after shifted autocorrelation, these values are squared, which is helpful, right? Okay, so now we can compare with then other common spreading spectrum codes. So PN sequence are probably are the most commonly used sequence for the spread spectrum, and also the common use for the scrambling, which is means NSF1. Effectively, they are deterministic plus minus one sequence that appears statistically to be the nearly identical to IID. IID means independent distribution. So, but only 0.5 sequence. So each value of the sequence is 1 or minus 1. So which equally probability and independent from the all the others, because if there are only two cases, one and minus one, so equally probability to come in the market, right? So for two arbitrary shifted or segment of the sequence correlated over NSF value, and both the normalized autocorrelation and the cross correlation are random variable with a variance of 1 by root n NSF. We recall the cross correlation energy is the square of the normalized sequence correlation. That value will be 1 by NZC, which is equivalent to the average cross correlation of the resolution of the same spreading factor. And thus on average PN sequence have the same cross correlation as a ZC sequence. That is the basically property we hold. So both have the cross correlation value will be same on average, right? But much higher autocorrelation. Okay, so that is about a cross correlation, not for a autocorrelation. In a PN sequence the autocorrelation much higher. Okay, corresponding to JC sequence. So this is all about the application part here written in this, and also just see in LT and 5G. So that is also used in LT, that is the 4G and 5G. So many key function initially download synchronization initially started from a download and uplink random access method, means the uplink, right? So initial download synchronization, this is the first step of UE to begin a connection of with a base station. Synchronization is not only for how to use acquire the base station timing, but also how to receive the key system information necessary for the subsequent communication. So especially the pieces is based on NGT3 sequence, and the value q is equal to 29, 34 and 25 are used. Okay, in a PSS mostly this sequence are used. And in the random access, which is how the U can access out to the network, because the U has not yet been admitted to the network, so it does not have the scheduled time and frequency slot for the uplink transmission. Thus the uplink random access channel should be the reversed to a many UH simultaneously transmitted at a slightly different timing offset. So that means the physical random access channel will be used and it's equal to N39 for a long preamble, and it's equal to 139 839, and for NZC equal to 139 for a short preamble. In both are used in LT and 5G. That means it's a range. So we mostly, if the long preamble, we can use NZC equal to 839, and for a short we can simply use a 139. Uplink control information, the physical uplink control channel PUCCS, that is actually short form, is used to in UE to the config channel state information and ACK, NAK as well as a request to transmit. All the UE share the PUCCH, that means the physical uplink control channel, to they periodically use it, and also benefit from the use of the spreading codes to allow multiple UE to send control information at the same time and frequency. So in LTE there are 4 PUCCH format, 0, 1, 2 and 3, and ZC sequence length will be around 12, and extended that in a ZC sequence you know that is will form a odd, but from a NZ equal to 11 sequence jets are used. We can show already in example 2. So are used for all the format 3. In a 5G there are 5 PUCCH format, and that ZC sequence will be 12 length. In that format will be 0 and 1. Okay, yeah. Uplink reference signal, that's also called a period signal, and uplink reference symbol are utilized by the base station for the channel estimation, synchronization, and are necessary for the demodulating the UE data transmission. In particular, they are used for a sounding reference symbol, that's called SRS, which are sent periodically when the UE is not transmitted data, as well as the demodulation reference symbols, that's DMRS, which is embedded with data transmission to add the precise channel estimation. In LTE and 5G NR, the length will be NZ is equal to 31, and that is cyclically extended in the frequency domain to achieve 36 length sequence for a SRS transmission, right? As far as DMRS, whenever signal carrier FDMA frequency domain multiple access is used, then the DMRS of the length 12 extended to JC sequence. This is always the case in the LTE uplink. In 5G NR, the uplink can be either of DMA or a SCDMA. So when the 5G NR uplink uses of DMA, then the gold code based on 2G, 2 maximum length PN codes. Gold code, that's when the 5G NR uplink use of DMA, then in that case we can simply use a gold code based on a 2 maximum length PN codes instead of a ZC sequence. So gold code is the just the extension of the ZC sequence that is maybe further used in 5G NR and 6G NR based on the confusion. So that is the basically part of is all about the ZC sequence from beginning to now word. So thank you for listening me. Bye bye.